So to understand what removing files, why removing files has on link as the syscall, let us talk a bit more about directories. And basically, we should start by talking about the same or the similar syscalls for directories, which is basically, for example, how do you make a directory? So if you strace make directory foo, you're making a directory that's called foo. You'll find that there's a syscall called mkdir, which is make directory, that actually makes the directory foo and gives it 0777 is its access property, its access bits basically, right? So make directory is a syscall that enables you to make a directory. An empty directory that you just made will have one entry that refers to itself and one entry that refers to its parent. So if you do ls minus a on the directory that you just created, you'll find dot and dot dot. The dot directory is basically a pointer from the directory that points to the directory itself. So it's sort of like it's the same point. It's a pointer to oneself. Dot dot basically points to the parent of the directory. Once you create directories inside this directory, then when you ls, you'll find also the children to that of that directory. And this way, sorry, this way you can actually, as we will see, manage the whole directory tree, the whole basically file system tree easily, because you always have a pointer to your parents. You always have a pointer to yourself, and you always have your children logged basically also in the in the file system. So let us give an example basically based on what we just said about like the dot and dot dot for an implementation of the ls command. So ls is the list command, which basically shows you that whatever is inside a directory, right? So this is a very simple ls a very simple ls implementation where you basically have the main. Okay, this is your main function, and you create a directory pointer dp, and basically dp is a pointer to a directory, and you call a syscall that is called open directory, which basically opens the directory. It's just like open file, but it's open directory, and you pass to it dot. So right now you're basically programmatically programmatically having a pointer to yourself as a directory. And then you assert that dp is not equal to null. So you assert that, well, that this pointer operation has happened, and then you basically create a directory int, which is a directory entry basically. Pointer. A directory int, dir int, is basically a struct. It's a predefined struct in Linux that basically has the following fields. It has the directory name, which is and a directory inode number, an offset to the next directory entry, the length of this record, a record length for this directory entry, and the type of file. Directory entry is basically the data structure that is used to store each and every element in your directory. So each file in your directory will have a directory int. Okay, so right now you're creating a directory int, basically pointer, and then you start reading into your into the directory int pointer that you have used using yet another syscall, which is called read directory, passing to it dp, which you defined up there, directory dp open directory. So passing itself a pointer to the current directory. And read directory is a syscall that sort of iterates. It's sort of an iterator over the elements of the directory. So it would read every element of the directory one by one, returning a directory int. Okay, so it's like a for loop over all the elements in the directory. So while you have data in your iterator, in your read directory can basically still read stuff. You printf the inode number of that element and the name of that element. So And then once you're done, once there are no longer there is no longer data that read directory can read, you basically close the directory, and you return 0. So in this is a very simple implementation of an ls command. To delete the directory, you can use the rmdir command, syscall basically. rmdir is implemented in such a way that it only deletes empty directories, because deleting a directory that contains data, that contains other data, can be quite dangerous, because you might not know, or you might not remember what are the files that ended up in this directory, and by deleting that directory you can lose important information. So the way that Linux enforces you, or makes you basically think twice before removing a directory, is basically by not allowing you to remove anything but an empty directory. So rm directory on a directory that has entries, okay, except for the dot and dot entries that has any data, will actually fail. There is another way to actually remove a directory even if it has entries, which is rm-r. It's basically it's a recursive remove command, which basically will try to removing every single element in your directory, every single file in your directory, and once done, it will also remove the directory. So it's sort of calling rm on the files, and finally calling rm directory on the directory. And rm, as we said, is not rm, it's actually unlink, and we'll talk about that right now. So what is the reason? What is a link? A link is basically a way that the operating system and the file system allows users to have two high-level names to the same inode number. Okay, so the link system call takes two arguments: existing path name and new path name. And what it does is that for the same inode number, it will create a new high-level name. Okay, let us look at this figure, where let's look at the left hand side of the figure. So you have an inode, which is basically a number, the low level number, that actually tells the operating system and the file system where your data is. So the inode number is actually where the data is. Okay, and you have a myfile.txt that actually points to the inode. When you create a hard link, and we're just now talking about hard links on the left hand side, you actually create a pointer, another pointer to the inode, which basically means that when you are removing a file, when you are removing myfile.txt, okay, unlink is called for that exact reason, because you actually only unlink myfile.txt, but my hard link will remain. And this is a way, because some files are used in multiple places by multiple programs, although you might not know that. So libc, for example, the C standard library, is used by Python, and is used by many other programs that are actually implemented using C. So it might be the case that if you try rming the libc file, because, well, I don't need the C programming language anymore, you still need the libc for Python to work. So you will have another hard link, basically multiple hard links pointing to the same inode that points you to the libc file. And using that, when you you save space, you save disk storage space actually, because now you just need a new basically name only, but pointing to the same inode. So it's only extra metadata, but it's not duplicating the data. So you're saving space, and you're making sure that no user will basically, because out of frustration, I hate the C programming language, I'm going to delete it, ends up with nothing working on his system. So this is how you create a hard link. So you echo hello into a file, you cat the file, you see hello, and then you ln, which is hard link, file into file2. So you have a file2 that points to the same file. You cat file2 and you get hello again. So if you ls minus I, basically showing the inode numbers for these two files, file and file2, you will find that both of them have the same inode number. Now, similar to hard links, we have the concept of soft links. Soft links are actually, or symbolic links. Soft links or symbolic links are actually links that they are pointers to the high level address rather than the inode. So if you look at now the right hand side of this figure, you have my soft link, which points to my file.txt, which points to inode, which basically means that if you unlink, if you rm my file.txt, my soft link will also die with my file.txt, because both of them are actually dependent on each other. So soft links is basically a way sort of to have a shortcut. I mean, in Windows it's even called a shortcut.